Before jumping into our case studies and panel discussion, I'll just throw a question at each one of you so we can get a little personal as well. Kevin, so my quick question for you is from a variety of systems and everything that the RMUS actually represents. What is your personal favorite and why?
Wow, it's a great question. And so there's one of the cool things about doing what we do and what I do is pretty much all these new systems come across our desk and in the workbench. And so I know the guys in the back get to really play with everything. And so we get to see a lot of these new ones. And I think right now, I would have to say that my favorite new system is I would say Wingtra, James, but I think that would just look like I was
I'd appreciate that.
although I do like it. So I think one of the coolest, most innovative products was actually the Vantage Robotics Vesper system. So that's a small SUAS, one of the blue SUASs. And I think there's definitely some questions about, the sustainability long-term of the product. But what I really like about it is it's a really cool design. It's very modular. You can clip the fuselage into different types of rotor systems. The batteries are magnetic. The sensor package is small, but incorporates a number of different types of sensors, not all of which are FLIR, so they've made some of their own. So it's a super innovative platform, and they've done some great things with quietness and flight range and things like that. And so even if it's not successful, ultimately the fact that they've really pushed the design envelope and really tried to do something different than the standard stuff, than just trying to build the same thing DJI or Autel is trying to build. They've gone totally different, and I respect the heck out of it. So that'd be my choice for right now.
We still have to see that one performing on site.
Well, we can help you out. And Wingtra is also awesome, James.
Perfect. And over to Rasmus. So from data acquisition perspective, what would you consider, for this year, what has been the most challenging project for you?
Yeah, I actually have a pretty good one. It was fairly recent. So one of our services that we provide is basically pre and post pond cleaning. So we use our LiDAR solution when we do this, due to the fact that there's quite a number of vegetative plants around this, and we need to strip do the post stripping analysis for the LiDAR data. So we did an initial survey pre-cleaning of the pond, and it came basically within 1 or 2 centimeters, I think it was less than that, to a survey done by a very reputable firm in Southern Ontario. So that was great. And then the company that we were hired by, the subcontractor, actually performed the cleaning, and there were supposed to be something like 600 cubic meters of silt removed. However, after doing the second LiDAR flight, it only showed about 140 cubic meters removed, and actually like 4 truckloads of dirt put around the site, which was a total discrepancy between, the work being said, the work that was supposed to be done, and the work and the data that we actually obtained. So it's actually quite interesting to.
That's a pretty large accusation to have for any company performing that service.
Yes, it is. And what's funny, that when you put the data side by side, you can clearly see that the accuracy and precision is there. So now we're kind of going back and forth, and another surveyor got involved and actually got the same results as us.
So someone has to come in to double check you to make sure this is actually credible.
Yeah, so that's pretty funny that happened, and basically it proves that our data was accurate on both accounts. And we actually ended up doing, because our in-house CAD engineering, we actually ended up doing both calculations from ours and the company that did the survey after. So we provided the results back, which is interesting, that we were still, credible enough to do the CAD work and get these results. But it's definitely a difficult situation to be in, where that your data is right, and how do you go back and be like, hey guys, you kind of cleaned where you shouldn't have, and you moved dirt where it shouldn't have been cleaned, right? So
yeah, it's client relations as well.
Yeah, exactly. How do you keep it, that that you're still professional and you continue doing work with the folks and have that trust relationship keep going, right?
Yeah. Yeah, I can see definitely that's challenging. Um, Last one, James. So actually, we met James through SciTech. I believe it was 3 years ago at least, right? We trained your team to help set up for your industrial drone solutions. Obviously, there's something that really attracted you from Wingtra to move from industrial solutions to just a drone company. So what really attracted you at Wingtra?
What attracted me? Is this an interview question? No, I'm just kidding. No, what attracted me is, it's a different solution in terms of vertical takeoff landing. You're getting the best of both worlds. You're taking off like a multi-rotor, and you map large area missions as a fixed wing. They've got a great culture at Wingtra that I thought aligned very much with who I was and my goals. And they've built having used the Wingtra for 3 or 4 years now, I understand that, the time and energy and the support that they've put into the product, they're building a very reliable solution out there, and the future looks really bright with them. We've got a great network of dealers here in Canada, great relationships with Kevin and his team here in Ontario. And it was just making the switch and going with a drone provider was something different for myself, because I like to be involved in all technologies, but the team here at Wingtra is great to work with. So that was a big decision factor for me.
And apparently they sent him a case of Toblerone as well, I heard.
Yeah, there was that went to my wife, not me.
So we have kind of 3 focused cases for us to discuss and really help everyone to understand, building a solution for the industrial sector using drones. First, we'll talk about how to deliver precision and accuracy. And then from there, we'll discuss the second case with a focus on photogrammetry, thermal, and LiDAR, basically different sensors, and why did we make the decision to go for LiDAR. And then the last one, we'll also talk about BV loss operations beyond visual line of sight, what to look forward to with the new updated regulations, and also share a case of our current year's BV loss project to really discuss what we have discovered throughout that project. So going back to the first one, talking about precision and accuracy, basically this is a very standard survey project, right? Typically, especially for subdivision. So similar to, RASBAN for your day-to-day operations of using drones to do survey. Ultimately, you're collecting geographical information about the Earth's surface, and then you're processing that surface information for the client. So it could be an engineering firm looking at the topography difference, right, before they budget and decide how much is the cut and fill and how much work or cost is involved in leveling and building for a specific site. Or it could be during the construction process of monitoring the progress, or it could be post, like the specific case you just discussed earlier about verifying the work that was done. And there's quite a bit of municipality looking at verifying. It could be subdivision that's built, verifying that the stormwater management, all the infrastructure facilities are built to design. So those are very common applications. But at the end of the day, when you are working with in a subdivision or in urban environment, the precision and accuracy is really important when it comes to industrial solutions. When we say centimeter accuracy, we say 1 to 2 centimeters. That reflects really largely, right, back to the project scale. Depending on what they're working on, it could cost tens of thousands, if not millions of dollars to fix, if that's the case. So I think one of the common things people ask about precision and accuracy is to what standards, because ultimately when we say precision and accuracy, we need to compare that to something. There has to be one that's the standard. So when we say achieving drone accuracy, what do you use actually as the standard to say, our data actually is 1 to 2 centimeters accuracy?
That's a very good point, Ife. So if I may step in, so the standard for subcentimeter, or what people call subcentimeter. It's actually anything less than 5 centimeters of deviation from a standard plan. So that's usually what engineering firms go by. Of course, this 5 centimeters can, to your point, if you're off by 5 centimeters across 30 acres of, let's say, cutting dirt, that could amount to many trucks. So there are many ways that, and again, sorry, maybe I should go back. Precision and accuracy. So there's a difference between the two, right? Accuracy is when you hit the target, like your bullseye, and precision is how many times can you repeat this over and over. So that those are the two things that people usually get confused between precision and accuracy. So I just wanted to kind of give a background of what that means. Those two can, with drone data, they really have to come together with some sort of ground-based benchmarks. So we use, for example, we use our rover and base station with ground control points, and we always have data. So when we go into a job, we have data provided by an Ontario land surveyor, in our case in Southern Ontario, and we go off by those things, and we calibrate our equipment based on those benchmarks. And then all the data that's obtained by the drone gets calibrated to what's actually on the ground. So you kind of do alignment. That's why it was important for us to have that in-house CAD engineering firm, so we can sort of make sure that all our data is snapped to that CAD drawing, which then ensures that we have the precision and accuracy needed.
Now, James, I guess turning back to the equipment perspective, what Raz was discussing about aligning to the benchmark. So from a drone perspective, I mean, traditionally when we talk about the GPS accuracy on the drone, we're talking about the navigation system on the drone for it to fly to the specific spot it's supposed to. But obviously when we talk about the data acquisition, that's actually different than the GPS, than the navigation system on the drone. Right. So from equipment perspective, how do you distinguish the two?
Yeah. So in terms of data collection with the drone hardware, you're looking at the sensors that are coming on the solution itself. So in our case, we've got different payloads of megapixels, 24, 42. Having a better resolution on the ground is going to translate to a better accuracy or hitting that benchmark that Raz had mentioned. And also having those higher resolution sensors is going to allow you to repeat that solution and make sure that you're, when you're layering that data on top of each other, and as Raz mentioned, the CAD and seeing how close you are getting to those benchmarks, you want to make sure that you're as tight to that as possible. So yeah, that would be, the different sensors and megapixels are pretty important on the solution hardware.
So if I understand correctly, basically as the industrial sector, the benchmark is almost serving as the standards where everyone has to conform to. So it doesn't matter if you're surveying using regular ground equipment or using aerial equipment. Both basically need to align with the existing industry agreed benchmark.
Yeah, exactly. So you've got your Ontario or Canadian land surveyor that would create that benchmark on a site, and then that's your point of reference. That's going to be your ground truthing, I guess you could use that term, and everything is going to relate back to that. So with different solutions, you've got RTK GPS, you have PPK, which are great options as well, that are going to be able to present and get you that tight accuracy. And you're always, when you're using an RTK or a PPK solution, you're referencing all of your imagery, all of your data to a known point that would be on site.
Right. Now, Kevin, I guess from your experience dealing with industrial clients, how many of those actually consider, to this degree when they're looking for drone equipment or solutions?
It's a great question, Yifei. I think it really depends. You have two different subsets, right? You have the professional surveyors who we deal with, who already know. So they live that every day, just like Raz says. So they're going to be asking a specific set of questions. and they're going to be, they're going to be buying very specific equipment based on the accuracy levels they need. And they don't necessarily need that sub 5 centimeter accuracy level on everything. And then sometimes they want absolute, like they care where it is in 3D space. Other times they just care on the accuracy of the model, right? And so they'll know to ask those questions. Where you get the challenge is you have a lot of service providers or a lot of non-surveyors that are being tasked to do this job, and they don't have a proper understanding of the actual deliverables. So James mentioned RTK, right? So if you don't know what that is, essentially, without going into detail, it's supposed to be a positioning system that you plug it in and it'll tell you exactly where you are in 3D space, right? And so DJI, for example, offers the DJI M300 RTK. So if you're not a professional, you're going to say, great, I'm going to know exactly within that 3 to 5 centimeters where my photos are, and I don't need to do ground control, and I don't need to do everything. And meanwhile, Raz is poking his eyes out and James crying here, but that's what people think. But in DJI world, RTK was a film thing, right? It was made for you, Yifei, to have the drone hover at a specific spot in the air. So it doesn't actually do anything. It makes it more accurate than regular GPS, but not survey level on the ground. So that's where we see it on the
makes it more
right?
repeatable as well. It makes it easier to create actual repeatable flights.
Correct. So there is absolutely a use for it, but if they don't understand what the end results are they've got to get, they're not going to do it. And then you mentioned LiDAR, that carries over directly into things like LiDAR, because that's a whole other different set of standards where people get widely confused. So I don't want to drag it down there, but I hope I answered the question.
If I may interject, Kevin, you're completely right. In fact, when I fly my missions, I have an RTK system. I actually disable it for the LiDAR missions. The LiDAR has its own GNSS, it has its own IMU. And in fact, when you fly those automated missions, what happens, having RTK enabled, in many cases, it constrains the flight of the drone when you do an automated mission plan. So it doesn't come out as well as flying as without.
So ultimately, what we're talking about is there is the drone. I mean, going back to earlier, right? We said there's the drone navigational accuracy versus the survey data accuracy. And the two are not necessarily the same thing.
Correct.
Yeah. One other thing too that I'll mention, like you mentioned, the positional accuracy with RTK. When you're doing your mapping missions, if there's any interruptions during that mission of RTK to that base station, that can compromise some of your data set and you'd have to start the mission again. So having a PPK option, it removes that connection between the ground station and the drone, and then you can geotag all of your images after and ensure that you've got accurate, reliable, repeatable data each time.
It's interesting we talk about this because I remember at the beginning of the industry when DJI first started releasing the RTK solutions, and there was a big wave of pilots who just wanted to buy these drones and started calling themselves the drone surveyors, which really upset the entire land surveyors, because surveyor is actually a legal title, a legal license title. But I believe really more from operate, like, for the past couple of years, we're seeing more and more engineers, construction professionals, they are really adopting the technologies, and they are the ones who are actually able to deliver the results. Because, going back to talking about precision and accuracy, it's not just about the drone data precision and accuracy. It's also about how you're delivering to the client. So Raz, I believe one of the service focus is also, like you said, the in-house CAD engineer. Someone has to process the data, align it with the original project's engineering, chart or the initial CAD design. Otherwise, what you deliver as the drone data or the survey data, it may be just raw data, and it may not provide the right insight to the client.
Yeah, that is correct. All the data has to be spatially aligned to something. So if you ask, my toughest jobs are when we are unable to obtain CAD files. We only get sort of, I guess, corrected PDFs. And again, I'm very thankful that I have a team that's able to take those PDFs and then turn them into CAD files in order to then further use it. Because without that, you actually don't know where the data is. Now, there are certain cases where you don't need it. So for example, volumetric calculations, you can kind of get away with it, where you basically compare two surfaces generated by yourself and then you use a software like Agisoft or Pix4D, etc., to generate some sort of data. But in most cases, for example, for my work, they're 99.9%. I need those CAD drawings.
And I guess the other topic that's of interest is also when we talk about accuracy, we talk about the centimeter accuracy, but also comparing to traditional survey, right? Traditional survey is someone walking with the GPS station or the rover, throughout the site. And depending on the size of the site, depending on the topography change, it's really up to that person. It's very subjective on what the person on that day decides that how many points they're going to walk and collect that data for survey. Versus the moment you put a drone up in the air, it's scanning the entire site. So I guess the first challenge for us we had from survey was it's providing too much and too dense information that, as it turned out, the engineering firm couldn't even open the file because they're used to, how many 30, 40 points, and now you're giving them thousands, if not millions of points.
Yeah, and it's all into the post-processing of these points, right? In a traditional survey, the person going on the ground will do anywhere between 3 and 5 meters of survey with your traditional rover and base station combo. Now, the beauty is when you do it with a drone, yes, you do get all these points, but if you have, for example, like how I have my team in-house, I can actually go to a little bit higher density, meaning you don't guesstimate the area between the points. So I know both James and Kevin understand this. Like, the more points you have, the more accurate of a model you get. This is, if you do provide this to engineering firms where it's super dense, they might not know what to do with it.
So you even have to de-densify the data.
Yeah, we de-densify and do quite a bit of a data cleanup. So it's not, most people when they get into this, and Kevin was talking about this earlier, he's like, yeah, I can become you said, I can become a drone surveyor. There's a lot of post work after the data acquisition.
Yeah, very similar to even filming, right? To capture an image or a video is the easy part. Coming back to run through post-processing, right? That's always time consuming. Before we turn to our next case study, I just want to quickly touch base on the software side because we talk about post-processing. So James, from Wingtra perspective, obviously Wingtra is on the hardware. It's an actual VTOL fixed wing drone. What are some of the survey softwares or capture softwares Wingtra is compatible with?
Yeah, so again, our goal is just to collect accurate, reliable data and be that workhorse in the field. But we're software agnostic. We work with any of the major suppliers out there: Pix4D, Agisoft, Bentley, ArcGIS, Esri. One for a lot of our aggregate and heavy earth moving companies would be Trimble Stratus or Propeller Aero, which is a great solution that is allowing our customers to make timely decisions. That having accurate data, and we're talking about precision, having that data that's going to help them today and then also in the future is super invaluable. So